Okay, so now we want to look at accuracies. Okay, so what are the different accuracy measures that we can have? Okay, so we have y is your target, right? So that's the now y hat, that is your prediction. Okay, so you will have this for one for each column. I mean each row. Sorry. So you have y, and then you have y hat. Okay. The accuracy measure is that each column you can find the residual y minus y hat. So that is your error. How much error there is between the actual value and the value that you're predicting. So that is called residual or error. Okay. The accuracy that we want is that the residual should be very small. If it is very small, then our predictions are reasonable. It's good. Okay. Smaller the errors, the better it is. But we have one error for each row, so we are not going to go through each and every number in the residual column. You have thousands of those. We have 2,000 something. So we have to summarize that. So there are several summaries that that we can use. So one is okay. So you can simply add. So that is called mean error. So that is ME, which is mean of the errors. So, but mean of the errors, some of the positives and negatives will cancel out each other, and you may, even though there are big errors, you may end up with a mean which is small. But it is a good measure to see whether there is any bias. If there are too many positive errors, then ME can be positive. A large positive number will tell you that there is a bias towards the positive errors. And similarly, negative, too high a negative number is a problem. Then you have what is called MSE, that is mean square error. So you take the y minus y hat, square that, each number you square and then add them up, and then divide by, actually the degrees of freedom is n minus p minus 1, but let's not worry about that. It is some kind of an average divided by degrees of freedom. Okay. And then there is absolute error. You can take the absolute value of each error and average them. That is mean absolute error. And then you can take the absolute error, divide by y, so that will be proportion. So M mean absolute percentage error. So these are the kinds of measures that we can develop. Okay, and that is done. There is a forecasting library that makes it easy for us to calculate all of these different measures. Okay, so we need to install that package. Install forecast. So select forecast library and install that. All right, so now we have the greater than sign, so it's done. Okay, so now we need to set up library forecast. Okay, and we will do message equal to false. Okay. Now, and we run that, and we have the library forecast done. Okay. And after that, it is pretty straightforward. You use the function called accuracy. So the library forecast has a function called accuracy, and here you provide the y and the y hat, okay, like what we had here. Okay, we say where the y is going to come from, where the y hat is going to come from, okay, and then it's going to automatically compute, okay. So we have, so let's look at train set first and then the validate, right? So you give the y hat and then the y, okay. Reg.res fitted values. Okay, so that's our y hat, and train.df total value, that's our y. Okay, so y hat and y. Okay, now you run that. So it automatically puts the label test set. Okay, so don't worry about that. So we can change that in a minute. Then we have ME, that is our mean error, or MSE is the square root of mean square error. You remember we did mean square, I showed you mean square error, which is that. Take a square root of that, that is R MSE. Okay, and then we have MAE, that is our mean absolute error. So you take the absolute value and then find the average. That is MAE. Okay, and then we have okay, we'll come back to MPE. MAPE, that is you take the absolute value of the error, divide by the target value y. So you're expressing the error as a percentage, okay, and then take the average. That is MAPE, mean absolute percentage error. And MPE is without the absolute. Okay, you take the error, divide by y. That is mean absolute error. Okay, absolute, but not as a percentage. Okay, so that would be like ME. There will be pluses and minus. Mean percentage error, sorry, I mean, you don't take the absolute, just take the error, divide by y. Okay. Now let's capture that in a vector, right? And then let's do the same thing for the valid set. Okay. The predicted values for valid set is what? Valid pred, right? Valid dot pred. Okay, and then valid dot df dollar total value, that would be the total value from the validation set. So now we have the validation set y hat and y, and we run that, and that will create the same set of statistics for the valid set. Okay, and then we can put them together So now we have x and y, okay, we have 5 numbers, right? Those 5 error measures, and we want to put them together, okay? So you can put them together as a row bind. So you take the row for train and then bind the row for validate with it. So R bind will do that. R bind x and y. Okay. So you have ME, RMSE, the same thing, but see that it gives the same name for both of them. Okay, so that's not good, is it? So let us go ahead and say accuracy values. Okay, let's put it in there. Okay, so we are capturing this into that, and then we will row dot names. Okay, we'll give names for the rows. Okay, accuracy values, right? Accuracy dot values, and we'll say the first one is train, the second one is valid. And then we will print accuracy dot values. I have an error here. There shouldn't be a space between the less than and the hyphen. Okay, so now I have it. Okay. Now you see that this is in scientific notation. Right? We can do this, say round it. So that would make sure that it's not in scientific notation. Okay. Now you may also, there is another way to avoid scientific notations around. Suppose you have lots of results that get produced and you don't want to put round every time, and you want the regular, you don't want scientific notation, then you can do that by assessing a penalty for scientific notation. So that is called options options, right? Science penalty, SCIPEN. So you put an arbitrarily large number, so there is penalty. So now you print that. You'll print the whole thing without scientific notation. It's not rounding now, so it's giving you the whole thing, but without scientific notation. Okay?
Our numbers will be different, right? Our numbers will be different.
Yes, that is true. I should have, I should have put a set seed here when we created the data set. Here, so here I should have done set seed. Then it would be the same. I should have done that. I forgot. Okay? All right.